Now, Robert Schoch, Dr. Robert Schoch, and he is a historian, I believe, Egyptologist with a Yale background and the University of Boston, I believe. He importantly pointed out there were verticalized rain channels as well in the enclosure area. That's also important. Those rain channels erode right through this differential erosion, which means the Sphinx enclosure is very, very old, far older than the 4th dynasty. There's no doubt about it. But this differential erosion between the Mose 5 and Mose 3 bands can only come through oceanic submersion. If it came through wind and rain, it would be verticalized, but it's horizontal, it's planar, which means it has to come through submersion. There's no doubt about that. And we have, of course, backing up in the background, another planar eroded structure, the Khafre pyramid, backing that up. Then finally, of course, the face is not eroded at all. It hasn't been eroded by wind, it hasn't been eroded by sand. It doesn't have the planar erosion of carbonic acid. That face was put on there at a later date, 2510 BCE by Khafre and his fans. So that face is a recent addition, no doubt about that. Similarly, if you go to the Giza Plateau, go to the quarry yard, the Mokattam stone quarry yard in the northwest corner of the Khafre enclosure, and you'll see these dissolved stubs, these stubs for the stones. They're highly karst eroded or carbonic acid eroded, yet carved into the wall just above these almost as completely dissolved stones are Old Kingdom hieroglyphs, and they're not eroded in the least, not a bit. So how do you get this severe karst erosion from rain and wind on stubs in the ground of Mokattam and nothing on the wall 200 feet down and immediately above those same stubs? Again, an autophaban, it's self-canceling argument.
What is forbidden often contains the truth.
What is forbidden often contains the truth. And we'll get through the end here pretty quick. Thank you for enduring this far. What is forbidden often contains the truth. Not always. That is it's a aphorism. It's neither a semantic truth nor a logical truth. But it's an important thing to keep in mind. We've been forbidden to grasp this principle. And we're going to talk here just what is a true polar wander? A true polar wander
cannot study what the heart will not allow.
We cannot study what the heart will not allow. My heart would not allow, when I saw the submersion of the Khafre pyramid, my heart would not allow a condition where we set in another rotation for 400 years. My heart was like, no, don't go there. And that was unfortunate because it was a painful process to come through that. What we have here is not the tilt that exists with Uranus or Venus. Those are obliquity tilts. They require added energy. Something happened to Uranus and Venus to go in those odd rotation angles. That's not what we're talking about here. What we're talking about, that's the Venusian retrograde, called a retrograde motion, actually. What we're talking about is in the center here, the relationship between the geomagnetic pole and then the rotation, what's called an Euler or Euler rotation of the outer body of the Earth around the core. In other words, core-mantle decoupling. It's this cascade here in the center. The left side is what we currently are rotating on. You can see the geomagnetic pole as GM there. The georotational pole as GR points at Polaris as we described earlier. And on the right, you see the retrograde or obliquity tilt type of tilt. That's what people keep thinking that ECDO theory is. And I'm like, no, if that's what you're sailing a straw man. That's not what we're talking about. The planet didn't tilt. That requires energy, tons of energy. But this relationship right here, the cascade from the removal of the geomagnetic pole or the excursion of the geomagnetic pole, as that transition provides degrees of freedom for the mantle to operate as a gyroscope, that doesn't require any added energy. That can happen naturally. And that's what we're talking about when we mean a true polar wander. It happens because of these structures that rise up from the core. They're called large low velocity shear provinces, LOVPs, but there are other LOSVPs, LSVPs, other names that they have for them. A concept is sketched over here. When I originally looked at these, I wasn't aware of the 104-degree angle principle of ECDO theory, but I developed a theoretical center of mass for what I call the Southern African LOVP or SAC LOVP, and it ended up in the nation of Zambezi, in the south part of Africa. That was where the centroid was. You see the principle here that as this material is sloughed off out of the core, you have hexagonal close-packed iron on the left. It's a very compact, high-energy form of iron, something we don't see here. Thor's hammer is made out of this material, reputedly. It's exotic in its nature. It produces an incredible magnetic field. It does things that we're not aware of. It's an exotic form of material, just like the hexagonal close-packed materials we worked with in our labs and analyzed. When you snap something out of a hexagonal close-packed lattice into this face-centered cubic, which this iron, normal steel is, you release tons of energy. And that energy, by the first and second law of thermodynamics, has to go somewhere, has to end up somewhere. It doesn't just disappear. So that's the principle there. That energy comes up in the form of heat at key points in the Earth. Actually, these are the centroids of the LOVP, sorry. And that's how I derive the centroid points. They are common to each other, so the mass or lack of mass that exists in the Pacific influences the location of the centroid in the south of Africa. So those are the points. There's the 104-degree rotation point placed and shown inside Zambezi in Africa. So I call them the PAC and the SAC centroids, but they're actually centroids of lack of mass, not centroids of added mass, because these are lighter structures. Then if you do the analytics to balance it out, we don't need to go into this, it shows that in theory, the difference between geomagnetic and gyroscopic rotation is 104 degrees, plus or minus about a half a degree. So as we look at the GRACE, gravity-driven moments here, we see on the left that the Earth does not actually rotate as a gyroscope right now. It rotates as an anomaly. And unless we introduce the geomagnetic pole, we don't actually have an explanation as to why we're rotating like this. So the solution is on the right. Once that geomagnetic eccentricity is taken away, the Earth rotates as a gyroscope and rotates this 104-degree angle. I call that the solution, or gyroscopically mediated Zhenebekov rotation. That's the accurate title there. Zhenebekov effect doesn't cause this. It's simply the pathway of least resistance between the 2 points in NP and NP prime. When we say that the Earth is locked, the core and the mantle are locked together, we have 5 factors that are locking them together, and these are important. We have what is called viscous coupling. It's akin to a shear earthquake. When a subduction occurs, one plate is ducking under another plate. They're locked together until enough pressure comes and it builds up and the subduction component cuts in, and you end up with that side-to-side earthquake that's so terrible. That's viscous coupling, akin to viscous coupling. The friction, if you will, it's not really friction, but it's similar to friction between the core and the mantle. Then secondly, the electromagnetic coupling, they're like 2 batteries. If you look at the main constituent of the mantle, it's olivine, which is not heavy in terms of mass of iron, but the contribution of the iron is accentuated in this olivine structure, and it produces a familiar rock, if you will, called magnetite, which is one of the strongest natural magnets that we have. And that's what provides the coupling between the core, which produces our magnetic field, and then the magnetic attraction to the mantle. It keeps them locked together. That's principle number 2. Principle number 3 is what drives an electric motor. It's called the Lorentz binding force. When you have a charged particle inside a magnetic field, if you try and move that particle, the particle produces a force. And that's what drives an electric motor. That also prevents the core and the mantle from decoupling. And then fourth, we have topographical coupling. It's like mountains in the wind, except the wind is big and thick. So the mountains won't move and the wind won't move together. They're bound together by structure. And then finally, we have a gravitational tidal locking, much akin to the lock between the Earth and the Moon. But that's the weakest of the 5 forces. When we look at it here, the sloughing of the core, that ball of butter that we put in the oven and it's melting, and then the weakening of the geomagnetic field eliminates every single one of these, with the exception of the gravitational tidal coupling. In other words, once the sloughing occurs, in other words, the climate heats up, and once the geomagnetic component goes weak, the geomagnetic pole begins its excursion and depletes 25% like it's doing now, or 100% almost during the Lechamps excursion period. then we're rife for that that gyroscopic rotation, state 2 rotation. So hence, that's the depiction there. Now, interestingly, when we go from state 1 to state 2, what we might be looking at in the next 200 to 1,000 years, or maybe 2030, depending on what math you're on, is a slowly increasing hot climate, which precipitates in a sudden true polar wander, that 104-degree rotation. Conversely, on the back end, we have a suddenly cold climate, which then precipitates into a slow recovery back to state 1. So we end up with all the features that we see inside our geologic and anthropological past, not paleological past, I guess. You know, bison frozen, or I'm sorry, I believe it was elk frozen swimming through a river. We end up with a sudden temperature drop and then a slow move back, coupled against a gradual increase in heat, but a very rapid rotation from state 1 to state 2.
True genius shudders upon coherence.
Oh, this is another aphorism, sorry. Thank you, Chaz. So, true genius shudders on the coherence of a clear next step. When I hit this point, I was like, oh crap, not that I'm true genius, but that was the answer. So I had to develop predictions and take this to the final step. One of the predictions was verified by Craig Stone at Nobulart. He basically found that of all the tectonic striations on the Earth, if you deal with them as a database, and he pulled down the entire database, and you find the concentric commonality to all those striation marks, they end up, both of them, or both sets, they're bifurcated along the meridian of rotation, and the center of each of those striation mark sets is right at the Euler or Euler axes, the western one and the eastern one. I about fell out of my chair when Craig produced that. A very prominent, successful confirmation. Not final proof, but very strong. This is what's called extraordinary evidence under the Sagan denomination. And then heat. Heat comes up through the Pacific, comes up through the El Nino along the coast of South America, and then the Pacific as well. 104-degree rotation, we won't dwell here. The rotation of the oceans, the displacement of the oceans, we have here indeed exactly what the rotation would expect. The Great Basin displacement, chevrons, the diatomaceous salt deposits, the saline deserts in the American Southwest, they're saying, well, that's ancient lakes. Their tributaries feed the salt into the depression. No, it's not. These are all at high elevation. There are no tributaries feeding these diatomaceous formations. How did it get there? Patagonia, clear evidence of striations from the east to the west. Sahara, clear evidence of striations coming out of the Med, and then by the Coriolis effect turning, hitting the coast off the coast of Guinea, of West Africa, and off that coast is the Mauritius Slide, the largest slide deposition on the Earth is right there, and it's all the topographical material displaced by this oceanic powerhouse moving through Sahara and then moving out off the coast of Sahara as the Coriolis force finishes it. And curiously happened right at about the time as what is called the aridification of the Sahara. Similarly, the Gobi Desert, the most massive displacement saline diatomaceous desert on Earth. The Great Victoria Desert, similar principle. All of them fit. Black soils displacement, they conform. It's almost like a snapshot in photography when you take a picture of someone, behind them is a shadow that's in that same configuration of that person. What we've got here is black soils displacement that takes the shape of the full coastline. Only one thing can cause that, and that has an oceanic displacement from that coastline. Similarly, we have the Russian black soils, and the Russian black soils actually have a Coriolis tilt to them as well. Same thing. So the coastline conformed displacement of black soils, completely different environment north of the displacement line as compared to the displacement line and southward from there. The Y-DNA compression, and there's been a lot of hullabaloo about this. Somewhere around 5000 BC, we lost 19 of every 20 people on the face of the planet. It shows up in the male Y DNA, where we lost 19 of every 20 males on the place of the planet because we had a severe constriction of the diversity of the male Y DNA at that time. And it happened in a very short period of time. The narrative attributes this to warfare, famine, pestilence. But if you run population models, if you know how to develop those models, you know that this can't happen globally. No war, no pestilence, just like COVID. COVID killed differently around the globe. No famine, no political doctrine, no practice, no patriarchy, no kingdom can produce this effect globally at the same time. There's only one factor that can produce this, and that is a significant cataclysm. Now, it could come from outer space, but it just happens to appear right at the, or occur right at the time, about the time of our last state 1 to state 2 rotation, which is the flood of Noah, Deucalion, Atrahasis, Gilgamesh, etc. On the female side, not as severe a constriction, it's more of like 8 out of 20. So the postulate is here under ECDO theory that men in the kingdoms that were wise and knew this ancestral tradition, they saved their cousins at the furthest reach. But the females they brought into their household could have been captives, concubines, servants, multiple wives. So the diversity survived. The individuals didn't survive, but their diversity did. The mitochondrial DNA diversity indeed survived because of these patriarchal practices. So that's explainable in the context of losing 19 of every 20 humans. And similar to the east Euler axis rotation point, in terms of megafauna, large animals, the most diverse survival point for humans, humanity, ancient rock art, 51,000-year-old rock art, all survived at that eastern Euler axis, as the theory predicts. Same thing on the western Euler axis. All kind of mysterious critters in the Peruvian and Ecuadorian Andes. They survived for a reason, and potentially they knew. And we see that there. So as we bear this in mind, there's the 104-degree angle, the difference between current North Pole and NP prime. So we have here, as we're getting close to the end here, the rotation between state, or the difference between state 1. State 1 is like this, we're rotating like this, and then the Euler rotation happens, but the Earth keeps rotating as it does normally, and under a conservation of angular momentum, the Earth just takes this orientation and rotates as it always has. No added outside energy is required under this type of rotation. And this is developed by Craig Stone at Nobulard as well. And you can see that under this rotation, the oceans will keep going where they used to go. The land takes on a new pathway, and the oceans keep going where they used to go, so the land and the oceans cross each other. The stones themselves cry out. This is where this is prediction.
Can only be understood by engineers.
Much of the past can only be understood by engineers, or maybe more specifically, cross-disciplinary experts. I don't know if you would call them experts. The spiral symbols. The oldest spiral symbols in Europe, this is a symbol that is ubiquitous throughout Europe. It's done in a variety of forms, but the oldest forms, 2 of which are depicted here, I believe that's Newgrange monument on the right, and then that is the Malta seat, temple seat on the left. They both show a rotation, state 1 rotation, separated by delta, which means change or cataclysm, and then on the right, a state 2 rotation. Those are the oldest depictions of the ubiquitous spiral symbol. From there, they get more fanciful, and I think we lost the cultural memory that allowed us to preserve this 2-state condition. These are the most ancient versions of them. We lost that cultural memory, and it just became a pretty picture that meant something important, but I don't remember what that was any longer. And that's what they're depicting. That's the North Sky to a navigator. You walk out on the bridge wing of the ship with your sextant, and you're going to take your night shots of your stars. You get 3 stars, and you take a low shot on the horizon, use a principle called homoto. You go in and put it on the chart, and you estimate your location. That North Star is what you look at, because that's the center point that everything revolves around. That's the point of God in the sky. Very important to ancient peoples. That's Polaris. Bearing north, the true north. There it is, Newgrange. Newgrange is pointing to NP prime. We remember NP prime is the North Pole during state 2. It is what ECDO theory predicted should be the obsequience of these monuments, and indeed, this monument actually points there. The narrative is that it points to the winter solstice. But in fact, it's 8 degrees off from the winter solstice. It's not even close. The only reason is because the sun catches the very end of this passage. But the inception of this passage, the cross at the inception of this passage is pointed right at NP prime. And you can see there are 10 other arcs that I've put there from these other monuments, and we won't go through them in detail. But they all intersect in the same spot. And this is only 10 cherry-picked out of the whole body of them. To date, we've had identified 93. 82% of ancient monuments prior to 500 BC point at NP prime. And we'll take a look at that in a moment. Chinese pyramids, hundreds of these pyramids, they all point at NP prime. So if you're in South China, they're angled slightly to the right. Why wouldn't they point at the same direction? If you're in North China, the Xi'an pyramids, they're angled slightly to the left compared to the south. They're pointing at NP prime. Sacsayhuaman, one of our most popular monuments now, impossible walls, impossible stone deformations, clearly points at NP prime. It's a touch off, but we accommodate that in the statistical study, which you'll see. We don't want to take that at face value. Poverty Point in Louisiana. The Tomb of the Giants in Sardinia. The Kokor in Cambodia. So this knowledge was all over the planet, including Gunung Padang in Indonesia. Gunung Padang is also aligned to NP prime, but I'd put it on here. The ancient city of Gore in Iran, the gates of the city are aligned to NP prime. There's no doubt about this. The Malta temples, the temples of Calypso, where Odysseus was held captive by the goddess Calypso to be her sex slave for 7 years. He stayed there for 7 years. He must have tried to escape often. But that temple is aligned to NP prime. The Nazca lines orienting reference, the mandala square, the entire Nazca line set is oriented around this central orienteering reference or surveying reference. It's aligned to NP prime. The Dickey stones, and the gentleman who wrote the foreword in my book, Ambassador Louis Luck, he lives in Costa Rica. He was chief of staff at the U.S. Embassy there for a number of years. And he's like, I can't tell the Costa Ricans this. Sometimes we love the mystery because the mystery engenders tourism and all kind of good stuff like that. And who doesn't enjoy a good mystery? But I think the Dickey stones, and importantly, Karahantepe, 100 years, possibly 100 years older than Göbekli Tepe, the axis is oriented to NP prime, 9,700 BCE, an important period here. Interestingly, Paula Zalitsky, oceanographer, and her husband, an engineer, oceanographic engineer, discovered numerous buildings off the west coast of Cuba in 2001. They measured the orientation of the streets and the buildings. They're aligned to NP prime. Underwater. The Piri-Reis map, which no one has understood, the Piri-Reis map is actually a consolidation of 3 maps. And I'm a certified navigator. I've spent 50 years navigating, 40-something years navigating. I graduated Annapolis Sailing School, qualified officer of the deck and navigator in the Navy. I've skippered 3 boats, navigated with them all. I understand charts and navigation. The central piece of a navigational chart is called its compass rose. There are 3 compass roses on the Piri-Reis map, and they don't agree. Sometimes you'll have 2 compass roses on a large navigation map like the Chesapeake Bay. It runs north-south, and it'll have 2 compass roses, but they have to agree with each other because you've got to use those references with your parallel rulers and your dividers and your pointers. They've got to agree with each other so you can navigate the Chesapeake Bay, and I've done a lot of that. None of these compass roses agree. The second aspect of Curio is none of these compass roses point to our current true north. Compass roses always have what are called primary ordinals, and there are 2 of them. There's north-south, and there's east-west. These have primary ordinals in the red, yellow, and blue lines here, but none of them point north, south, east, west, curiously. And they all don't agree with each other. So I did a principle, the navigation, it was just called chart mapping, chart matching. If you take a chart that you used in the Sea of Marmara off the Mediterranean, and you take a chart that you used in the Gulf of Mexico, and you take a chart that you used in the Pacific Northwest, their compass roses won't match up. But when you extend the line northward from those compass roses, they'll all intersect at our current North Pole. So that's what I did with these compass roses. I took their primary ordinals and extended them out in every direction. All of them were incoherent except for one. One, which was the north ordinal, they all intersected at, guess what, NP prime. Extraordinary evidence that explains that the Piri-Reis map was derived from 3 maps that were developed during State 2 and then digested by Piri-Reis, the Turkish admiral, into one map. He didn't really understand why it was constructed this way, but thankfully he was faithful to the original maps. These original maps were probably destroyed for a reason. All the monuments, this is the Marrow Build Reps, full set of 328 monuments. When you look at the axis of them, if you project the east-west axis, you get a moving North Pole. But if you project the ECDO north axis, you get a static North Pole at NP prime. 82% of these monuments conform or are subsequent to NP prime.
Hold on a moment here, Roger. What you are telling me is that 80% of ancient monuments dated to older than 500 BCE all point to a single spot on the globe, and that spot does not correspond to azimuths of winter or summer solstice sunrise, sunset, lunar pathway variance, nor equinox or equilux, nor the current North Pole.
That is correct.
Do you have a rigorous statistical study which accommodates all these possible confounders and still excludes the null hypothesis of random or non-NP prime alignment?
Absolutely, and that's the final thing we'll look at here. Of the body of monuments, this analysis was done. We were at a success set of 46. It shows 2 things. Number 1, yes, there is an obsequence to NP prime among ancient monuments. 2, it performs in a descending histogram. This is a histogram, is what it's called here, showing that the older the monument is, the more it tends to remember NP prime. A curious artifact. Now, part of it is rendered noise by our mismatch in dating. These monuments are likely older than we attribute them to, but we made the same mistake that we made with the bakeries at the Khufu Pyramid. We presumed that the human activity that we dated there was the cause of the monument that sits beside it, and that's not indeed the case. So we have definitely shown inside the statistical study that the cultural memory exists and the obsequience to NP prime, just like we point our roads true north today, exists. In fact, it exists such that here is the cumulative distribution arrival. It is the chance of this being accidental or driven by solstices or sunrises is 1 in 4 times 10 to the 14th, or 1 chance in 400 trillion.
They push their bookend lies to extremes to trap your mind. False choices left and right, while the real truth gets left behind. He saw through their science game, the hustle and the con. Questioned every story that the big boys put upon. Stood tall when COVID hit and the whole world lost its head. Wouldn't swallow their dark medicine or follow where they led. Held his ground through the madness, wouldn't bow down to the fear. Kept his soul on fire while the
In 1986, the band Metallica released a song called The Thing That Should Not Be. And it spoke of tumultuous forces that threaten mankind, not just existentially, but spiritually, just to disrupt our fairy tale understanding of our world around us, to reveal to us how minuscule we were in the face of the forces that drive the cosmos and, of course, the earth itself. With ECDO theory, we face the thing that should not be. In coming through this journey, this road to Emmaus, I think we see on the other side something extraordinary, potentially extraordinary, something that will take mankind from its childhood and into the light of the adult cosmos as we were meant to be originally. I look forward to the presentation tomorrow with you as well. Thank you. So this is presentation 2. This is the final chapter or sections of the book, sections 4, 5, and 6, and of course they're presented both in hypothetical diligence order as well as persuasive order, which is convenient. So this was basically just a replication of the finish out of the book. We begin out with the earth cries out. These are specific things that are happening inside and on the surface of the earth that are extraordinary evidences in support of ECDO theory. Then we look at the prescience of Giza. Giza under ECDO theory is absolutely the central message from the ancients delivered as a gift to us as modern mankind. Giza is the only monument that points simultaneously at NP prime and at our current North Pole. So it's trying to communicate that message to us. Whether or not Khafre was placed there because they knew how high the waters went, that's a distinct possibility because this is a regular event, a predictable event. That's a possibility, or whether it was just an accident. Either way, we got fortunate that we got the watermark on the Khafre pyramid that allowed us to at least be tantalized by the first clues. And once we look inside Giza, we see additional clues. And I know there are a lot of incredible coincidences about, especially the Great Pyramid or the Khufu Pyramid, passages and distances that match biblical intervals, or it looks like an explosion occurred in the King's Chamber. And we've heard those incredible claims in the past, and here I'm using the word claims, some of them are, or these incredible hypotheses in the past. I think that what we're going to see here today is a fully fleshed out, again, mature hypothesis that bears all 7 elements of hypothesis that hasn't been posed to date, even though it's one competitor among a field of many. I think that this prescience that we're going to examine here is very, very strong. And then finally, the diligence and reckoning. I spoke about the 7 generalized objections that both Grok and ChatGPT brought up and said, hey, look, I instructed them, hey, I'm going to dismiss the ones that really come from ignorance. And they were like, yeah, that's fine. But the objections that don't come from ignorance, can you summarize them in 7 bullet points for me so I can fairly address those? That we're going to look at here as well. And that's the diligence and reckoning. We'll go briefly through the 35 predictions, not all of them, just touch on 1 or 2 of them, and how 34 of them have come to fulfillment. All of them in that category of extraordinary evidence that Carl Sagan demanded. So
the
we
surest
begin
way
out.
not to find something is simply not to look for it.
The surest way not to find something is simply not to look for it. I forgot we had Chaz on that portion of the slides. So anyway, what I did was, with ChatGPT, I put it in skeptic mode, not cynic mode, and not fanboy mode. My ChatGPT is definitely in fanboy mode toward ECDO theory, and I'm okay with that, but I have to coax it back into skeptic mode. So it takes more of a neutral central stance. It says, wait a minute, have you considered this? And maybe you're doing a little overreach over here, but not in cynic mode where it's just throwing out rhetorical garbage. So what I did was I recorded each of these out through AI and then submitted them to ChatGPT and said, have I fairly represented your objection here or concern here? And it blessed or rejected each one. So it is ChatGPT speaking, even though it's a recording. So if we don't look for these things as a culture and as a body scientific, the point being as we enter into this section 4 of the document, that we're surely not going to find these things if we're not looking for them. And I'll remind you again of the aphorism we had earlier. The mind cannot research what the heart will not allow. We have to bear those in mind. So this presentation 2, presentation 3 is a little different. We'll be presenting off the actual website tomorrow. Presentation 3 outlines the argument, the hypothesis, the flow, the critical path, all these terms I sling around, of the book that will be published in December, well, probably October, but hopefully sell well in December of 2027, and you'll get a preview of that here. So presentation 2 is the finish out of the ECDO.
No qualification grants you the right to demand my ignorance.
No qualification grants you the right to demand my ignorance. As long as I'm buoyed by the evidence, I can continue to investigate this. It doesn't matter if they consider me a non-expert, which would be an invalid categorization, but I can still, we are propelled by the evidence, not by hype, not by conspiracy theory, not by all these things they claim. We are compelled by evidence, just as will be outlined in this section here, the earth cries out. So climate change, this is the infamous or famous carbon and global temperatures curve. And I've been running it to match and replicate what climate science has been producing over the last 15 years. I think this is ended in 2022. That's the last time I ran it, because it's basically the same thing every year. The actual global temperature curve is proceeding linearly, but the atmospheric CO2 curve is accelerating. And the way you look at that, nonlinear, accelerating, it's in a curve motion. So in order to keep this chart looking like this, I have to adjust the regression, both regressions every year, and get them aligned. In this instance here, both regressions are aligned. But in my need, or climate science's need, to adjust these statistics every year to keep them lined up, it highlights a mismatch between the progression of global temperatures and the progression of CO2 concentrations as measured at the Mauna Loa Observatory in Hawaii. And that presents a problem. What it tells me as a systems engineer is that in terms of carbon, there's more than one factor at play here. And there's an acceleration that's involved here that is not matching mankind's activity. Mankind is increasing their carbon release activity, certainly, but it's less than linear. So how then is carbon accelerating hyperlinear? It could be methane decaying into CO2, but we'll have to take a look at that. But it broaches the question as to why is that orange curve accelerating? And that presents a mystery. This is called the Keeling curve. And basically, the first mystery that it shows me is this thing called the vernal jump, right here. This is a normalization of every Keeling curve that arrived in Earth's northern hemisphere since 1973, I believe it is, which is our relevant range. I've got it indicated somewhere. 74, yes, good. Our relevant range of climate change began in earnest in 1973. And you'll see here a little bit later that some rather anomalous events occurred in 1973 that have nothing to do with mankind's carbon output that precipitated this entire set of changed events. But what we see here inside this Keeling curve is that every pre-spring, the carbon dioxide builds up in the northern hemisphere atmosphere. And then once we get the greening of the northern hemisphere, the trees begin to sequester and use naturally in their photosynthetic cycle, they use that carbon dioxide and decline the Keeling curve back down to a negative, which would normally be good news. However, the decline cannot overcome the increase each year, so we have a net increase in carbon dioxide, and that's what precipitates the long-term curve, is that differential. Each year we used to take away, through the greening of the planet in the northern hemisphere in particular, because most of the Earth's mass is in the northern hemisphere, we used to take away all the excess carbon dioxide that we produced in the off-season, if you will. And now we have a 30% shortfall. That nominally is the source of this excess carbon parts per million, what they call the ppm. And that 30% contributes each year in this Keeling curve. But what happens is, during the winter, this curve flattens out. And it shouldn't. If this curve was caused by mankind, we shouldn't have a flattening of the curve in the winter, because we consume more fossil fuels in the winter than we do in the summer. So why do we have a flattening, relative flattening of the curve during the winter? And then when the sun crosses the equator on the March 21st equinox, we have what I call here the vernal jump. And the vernal jump is simply means that for some reason, all of a sudden, carbon dioxide just springs forth across the whole planet. But it's not plants, it's not decayed plants, that's not gonna happen over 4 weeks, a 4-week jump. So a second mystery here is, what is the cause of this vernal jump each year? And that's the difference between the flattening and the vernal jump is shown right here. So those two observations in the annual normalized Keeling curve, one, climate science hasn't run this. They don't look at this. Number two, both of those are anathema to carbon dioxide under the definition of mankind producing all of it. Now, under this model, we can burden it definitely by mankind being part of the problem here. It could be 20%. I don't think it's 50%, but it's somewhere mathematically in this, maybe 20% of the equation. But that's inductive, not deductive. It's only hinting at the answer. Suffice to say that when we look at the Keeling curve from a systems engineering perspective, and not the way climate science has treated it, we see two intrinsic problems which stand to potentially falsify our current understanding of climate change. Again, not definitive, it is more suggestive, inductive, but still plays a role in scientific development and deliberation. Now, two experiments that we saw, and this came back during the COVID timeframe. This came out during the COVID timeframe. I thought it was curious that when I normalized all the Keeling curves from 1974 through 2021, I believe on this one, 2020, that in 2018, we had an interesting effect. That 1 year, we had a departure of the CO2 parts per million curves, in that it ducked below the normalized reference. Why 2018? 2018, we didn't do anything different. And so that perplexed me for a long time. It continued into 2019, and then into 2020, and my concern here at the time when I formulated this Keeling snapshot was that something had to precipitate that depressed parts per million curve in the northern hemisphere. I didn't know what it was, but something had to precipitate that against the normalized reference. So then along comes COVID. Woohoo! During the heart of COVID in the Western Hemisphere shut down. We consumed, what is that, 18%, I believe? Or is it 16? It's right in there. But we consumed way beyond climate change's goals in terms of reducing mankind's carbon or fossil fuel consumption. Well beyond the goals to save our planet, to eliminate that 1.5 degrees Celsius increase that we're well underway in completing. And curiously, during that same time frame, we had the largest ppm jump in the northern hemisphere in recorded history. So 47% of the planet is shut down, yet we have the largest ppm carbon dioxide jump in recorded history, right during, by the way, the vernal jump. So why is that? Why is that? These things began to pique my interest that, again, climate science doesn't look at the normalized Keeling reference here, so they don't know this. And so as I go back and look at the China curve, we look at the China curve, excuse me, I tipped my hand there. We look at this depressed curve from 2018 through 2019, and we look at the succeeding curve in 2020, we notice that that jump occurred right as China left its lockdown. In other words, when China resumed full economic activity, that's when our Keeling curve, ppm curve, jumped significantly. In fact, the precedent there would match, would be unprecedented in recent history, if you will. So I put together the hypothesis that the West is not contributing that much to the equation, but that possibly something happened in China in 2018 and 2019 that we were not aware of. We were acutely not aware of, except I was CEO of a company then called Grainster, and we were doing animal products trades out of China. Chicken paw, I never knew it was called a paw. I'm like, what's a paw? Like, you can't say that to these traders. I'm like a systems guy, every single trade was canceled because China was hit in 2018 at the same month with pig viruses, horse viruses, chicken viruses, avian viruses. There were a couple other viruses as well. They lost that in late 2017 into 2018, they lost 65% of their swine herd. And so that piqued my interest as well, that some type of activity occurred in 2018 and 19 in China, and China did not own up to that to the rest of the world, and it came commensurate with the release of a whole host of coronaviruses all at once, including two particular coronaviruses of concern, Omicron and then the Wuhan strain, which are different viruses. One did not evolve from the other. They were in situ different, and I ran the genomic analyses to prove that. So I put together, and we'll just touch on that briefly. When we looked at Omicron, when it arrived in November of 2021, there was BA1 and BA2. When I pulled down the entropy-driven nucleotide site differential between those two, and that simply means, entropy-driven means, are the mutations happening at sites that are slow to mutate? Or are they happening at sites that are fast to mutate? Because not all nucleotide sites mutate at the same rate. All the mutations between BA1 and BA2 were at slow to mutate sites. The distance between BA1 and BA2 was 5 years of evolution. So the challenge back to me by genomic scientists was, well, that's because COVID evolves fast. So I pulled down GenClad, pulled the entire cladistic inventory of COVID mutations, and saw that COVID mutates exactly at the same rate of all other 4 human coronaviruses, which is slow. It doesn't mutate fast at all. So that de facto answer that was handed to us was incorrect. There were 2 different Omicron viruses the day we discovered it, and they were 5 years mutated apart. So I put together the conspiracy. This would be connect the dots. This would be linear induction. Apologies, sometimes you do that. That Omicron existed in 2017. It was released commensurate with a whole host of other viruses. There were all coronaviruses, and China kept it quiet and then pretended that Wuhan appeared December 29th, 2019. And that Omicron didn't exist. And then when we found Omicron in November of 2021, we pretended it was brand new, and it wasn't. So the possibility exists that this carbon curve was depressed because the entire agricultural output of China had to shut down for a significant period of time under a coronavirus, a panoply pandemic of coronaviruses that occurred at that time. But anyway, that's a side observation. Regarding 1973, this blue curve here, these blue bars on the lower left panel, that's the infamous Gell-Mann curve. That's called the hockey stick graph. The inflection is the point at which a chart or graph or set of numbers make a significant alteration in their trajectory. The inflection here occurred in 1973. Curiously, if you look, and this is the release, these are global temperatures. Curiously, if you look up here, this is the progression of the geomagnetic North Pole. It began its chaotic patterning in that same year, 1973. And then we have a team of individuals who are putting together descriptions of our polar motion, and I think Craig Stone did this one, put together an absolutely prescient graph here that shows a significant core and geomagnetic moment mismatch that occurred as a pulse in 1973. So we have an exceptional pulse that really was only matched in one other year, and then this current one right here, that's a little scary, but I'm cautioning, don't jump to conclusions either. But we have a significant event that occurred right when the pole started taking off across the top of the Earth toward Russia, and right when the temperatures on the Gell-Mann curve had begun to escalate. And at the same time, the geomagnetic field, this is the velocity, I'm sorry, not the field strength, I have that in another chart. This is the measure of the actual velocity, geographic velocity. It took off like a banshee come 1973. So something happened in 1973, whether they're all connected, I don't know for sure, but we have to entertain the postulate. There's enough evidence here that we must consider it in the plurality. And we go back to Occam's razor. Plurality should not be posited without necessity. What we've established with these last couple charts is necessity, no doubt about it. Doesn't mean it's true, it's inductive, but we have the responsibility to examine it as a scientific community or a population community. In 2023, we had a strange event occur, and this really helped reduce down the challenge. This is called consilience under philosophy and the scientific method, where we have the intersection of multiple observations that agree and point in a certain direction. In 3 weeks of 2023, we introduced 40% of the entire climate change, temperature change since 2015. And think about that. 40% of the entire change in climate temperatures since 2023 arrived in just 3 weeks of 2023. Okay, well, it's a chaotic system and those things happen. It was El Nino. Well, El Nino, remember the first law of thermodynamics, the conservation of energy, both potential and expressed energy. El Nino has to get that energy from somewhere. It's not the origin of this heat. It's the channel of the heat, but it's not the origin. It's not an explanation. It's not a causality. So if we ask the question, where did this heat come from El Nino? And of course, whoops, I bumped us way back there. They shouldn't put these buttons so close together. So if I look at this heat's arrival, and I calculate what are called the ergs, which is the US system of physical energy measurement, particularly as it pertains to heat. If I calculate the ergs that are involved in this, if this heat had come through the atmosphere, as they claim, we would have lost a significant portion of mankind from the just being, there were several countries and regions that would have increased the average temperature for the year by 8 degrees Celsius. That's how powerful this heat signature was. There's no possible way it came through the atmosphere. Ding, again, climate change fails a significant deductive observation. That heat could not have come in that short a period of time through the atmosphere. So the second contention is, we've got a second candidate that has passed Occam's razor, and that's solar activity. There's a thing called TSI, total solar irradiance. Is it possible, one of two things could happen. Is it possible the sun put out a higher TSI? Well, we look back at I forgot the name of the satellite, the monitoring And the answer was no. TSI from the sun is pretty darn fixed. It's a well-known budget figure in climate change. Its degrees of freedom is very tight. In fact, exceptionally tight as those types of measures go, physical measures go. So we pretty much know what the sun's TSI is, and we monitor it very, very heavily, very closely. The albedo of the Earth, the potential that we trap more energy. Again, that doesn't exempt itself from the atmosphere argument. If that heat had come through the atmosphere, either trapped by the sun's more infrared range of frequencies, or if it had come through just direct temperature increase in the atmosphere, again, we would have had a significant impact on mankind. 15% of the planet would be suffering and requiring a dramatic assistance from the remainder of the planet. So this could not have come through the atmosphere, or could not have come from up above. And it couldn't have come from mankind, because we didn't amass all 18 years of economic activity in 3 weeks. So there's only one place where it hit me. There's only one place where this surge of heat could make its presence known, could channel through and arrive in our oceans. And this is called sea surface temperature. I neglected to mention that at the beginning, daily sea surface temperature. If that heat arrived in our oceans that rapidly, there's only one place it could come from, and that's from below the oceans. And that's a logical reduction or deduction there. So that observation is really what lit me off a lot on this course. As I look back through the Keeling-related heat curves that arrive each year, you can see that this is a repeating pattern. We'll have 1 year where an extraordinary amount of heat arrives, and then we taper off and retreat back from that surge. It's not how man's economic activity works. I've run economic models. I know how India and China's economic cycles. I've modeled them for clients. It's not how the US works. We do have some product shipping surges, and I've modeled those. That was part of what we modeled for the Chinese value chain strategy that my team did for Wang Qishan. But those models cannot in any way explain that surge or these surges. So what is causing these pulses is the question, the next critical path question in the sequence of logic. So we kept asking those questions, looking at the pulses, the pulse bands. And if you look at it, 2 observations derive from these pulse bands. Number 1 is that ocean currents speed up when these heat pulses arrive. Ocean currents come from the impetus of the kinetic energy that exists in the abyssal oceans, which is the deepest portion of the oceans. There are 3 segments of the oceanic structure or strata. The surface ocean, deep ocean, which sound like it should be the bottom, but it's the middle, and then there's the abyssal or abyssal oceans. That's about 4,000 to 6,000 meters globally. When that layer heats up, that's what speeds up, that's the impetus, that's the engine that drives the speed of global ocean currents. Now there are subsections of that, like the Atlantic Meridional Overturning Current or the El Nino Current, that will have their own velocity based on the kinetic energy in those segments of water, those currents. But when all the oceanic currents speed up simultaneously, that's a whole different thing. In fact, when we look at it, over the past 20 years, every single ocean current on the planet has sped up by 25%. And I looked at it in the tidal charts. We'll look at that in a second, and we'll show what that principle is. But metered with that was this observation, that as the heat arrived in the oceans, the SST temperatures, and that's these bands here, and I have these in full color and more detail on the website. I had to sort of reduce this down for the publisher. The publisher's like, these charts are too detailed, I cannot print them. And I'm like, I understand. But what we have arriving here is the ocean heat, and then immediately following that is an increase in temperature of the atmosphere. In other words, exactly the opposite direction. And it was consistent. It happened twice in 2023. The ocean heated the atmosphere. It wasn't the other way around. And then a second principle occurred as well in 2023. In March 2023, we had that large jump, a record temperature jump pulse, that 2023 pulse. 38 days later, carbon ppms made their largest jump in a long time, and I want to say in history. In other words, the temperature that arrived in the surface of the ocean precipitated the carbon release and not the other way around. So we have, by direct deductive observation here, especially with 2023, that made it clear. Prior to that, it was a little murkier. I gotta hand it to them there. It's not as clear in the previous years. But in 2023, the signal was stark. The energy had come from below, and both the carbon dioxide ppms and the atmospheric temperature jumps were the result of the oceanic temperature increase that had come from below. That was a stark outcome for 2023, caught a lot of people's attention. I felt privileged to be the one to observe it, but I think maybe there are climate scientists who can't speak who probably saw this because they're close to the data. It's obvious. So I don't know why they're not speaking, but they don't. So, you know, as a navigator and a sailor, I spent a lot of time taking ships in and out of the various East Coast harbors and various international harbors. And one of the things you look for is mean low water, mean high water. And you want to plot that out because, like in Charleston, if you pull in, the mast of the ship will just barely clear the Charleston Bridge. And if you're officer of the deck, you're there like confident in your calculations. You're standing there and all the sailors are watching you and you're just like, yes, I'm sure of this. This is going to be good. We're fine. And the quartermasters are usually the cockiest people on the bridge. Mr. Cunningham, are you sure we're going to make this make it in the bridge? And I'm like, oh yes, oh yes, oh yes. And you're standing out there watching it, and there's this optical illusion. It's so you swear it looks like you're going to slam right into the bridge. And even if you run the numbers 10 times, it just scares the crap out of you. And then all of a sudden you see it going under the bridge, and you're like, oh God. But you can't do that in front of the bridge crew. You just stand there and go, see, we're fine. And I'm sure that's how many captains were born during World War II. But anyway, one of the variants in that calculation set, and you have to run it down in run it in the quartermaster's shack and do it many, many times, maybe even have people check your math, is the mean high water, the high tide water. But what's happened is, of course, when we look at these NOAA stations, these tidal monitoring stations, sea levels have risen according to those tidal monitoring stations. There are various arguments as to why. But let's set aside that issue right now. And let's look at a secondary issue here. The variance between mean and low high water has changed. I'm like, how can that happen? And that's a problem because if I was going through the Bosphorus Straits under a bridge and I cleared it 3 years ago under mean high water, I may not clear it this time, even though I'm sure I can clear it because I've done it before. That's the problem with this dilation of the distance between mean high and mean low water. What would cause mean high water and mean low water to dilate like that? The answer is the local currents. The currents sped up. So when a current comes in 15, 25% faster, it ends up in a higher surge than it used to. And when it exits 15 to 25% faster, it ends up with a lower ebb than it used to exhibit. That's what causes the dilation between the high and the low. That is a bigger clue than the simple matter of ocean water levels rising. So what would cause that is the question that arises in the mind of a diligent investigator, a navigator. What would cause this dilation? It's the speeding up of our ocean currents. Now, when you calculate the energy required to speed up all of our oceanic currents by 25% in 20 years, the energy requirement is phenomenal. So much energy that if it was just delivered by temperature, we would lose our entire agricultural capability on the planet, except for in several favorable zones. So there's no way this energy, this kinetic energy to speed up these currents came through the atmosphere. Absolutely zero chance. Again, this is deductive critical path falsification. It's not suggestive. It falsifies the main tenets of climate science. So we depart from there and we start looking at maybe the cause that's entailed here. The error that climate science has made is what we pointed out yesterday, that they made an assumption in the climate budget as to the heat that is coming from geothermal activity. It's 0.087 watts per square meter. That number wasn't defined in 1880, but the principle was defined. And it's not that the number is wrong. It's that we ignore a thing called degrees of freedom. So we talked about the TSI of the sun. The sun is, I believe, 286 watts per square meter. This is a big number, so the sun is certainly big, but it stays affixed to that number all the time. The degrees of freedom, it doesn't wander from that number much. However, when we look at the heat that comes through the base of the ocean and underneath the tundra geographic regions of our planet, the degrees of freedom of that number are 10,000 to 1. In other words, there are hot spots all over the earth that we haven't measured at all. In fact, when you look at what we've measured in terms of the actual output of geothermal energy underneath the ocean, we've only sampled 3% of the Earth's ocean bottom in casual surveys. We're missing 97% of the equation. So the argument that this thermos Earth argument that energy that we saw yesterday is released from the core as it sloughs off that hexagonal close packed material and it converts to face-centered cubic, that argument is sound and is not addressed by climate change because we have chosen an appeal to ignorance. That simply means, that's a fancy philosophical term saying we ignored this subject. We went with our 1880 explanation and said, we're good, let's blame it on mankind, we're done. And that's what happened here. So what happens here is that we use a program called Argo to measure global temperatures in the ocean. And Argo is a fairly, it's a statistically significant sampling program in the jargon. It fairly represents the ocean temperatures from 0 to 2,000 meters deep. That's the surface. Then from 2,000 to 4,000, I love that it's nice and even like this, 2,000 to 4,000, that's the deep ocean. Temperatures there, we don't measure them, but they haven't changed that much. Then we have a segment of the ocean called the abyssal ocean, and that's from 4,000 to 6,000 meters. We have not looked at that segment of the ocean at all, really. And that's the onus that's upon us. We only look at the top of the ocean, which is a derivative temperature. And we do not look at a potential origin for the temperatures that we're observing. And that's down here at the bottom, and I've got it earmarked here in the bracket to the right. 1890s, did I say 1890s there? It might be 1890s. So it's one of those two decades when we came up with this principle, thermos Earth principle.
The surest way not to find something is simply not to look for it.
So we never looked. We chose to ignore it, which means we appealed to ignorance in the philosophical jargon. So I went ahead and put together a chart that pulled down two of the most recent studies on the heat content, as it is called in thermodynamics. Check me on that, make sure my jargon is correct. In thermodynamics, the heat content in the abyssal regions of the ocean. So when we look at this, there's a study called the DeBryer study that outlines the change in temperature from the period, and I've got the period outlined up here, 1993 to 2017. Significant period of kinetic temperature increase inside the oceans in general. The DeBryer study curiously spotted that in the abyssal oceans, there was a significant temperature increase. But they didn't see it as a problem because the temperature increase was not that poignant, not that severe. But I disagreed with that because here's the problem. When you measure the temperature of the surface, it's at one point of elevation. All that temperature is concentrated basically 3 inches underneath the surface of the ocean, which is the same height in general, other than being an oblate spheroid, across the whole Earth. So all that temperature is concentrated at one measurement point. Of course we're going to see that. But when the temperature is distributed across the bottom of the ocean, and you can see what is called the hypsographic taper curve, that means the amount of water that is contained in those areas, you can see that the bottom of the ocean is an uneven, highly distributed band. It's a region, a range in which these temperatures can occur. So in order to compare these deep temperatures, or these abyssal temperatures, with the surface temperature, you have to do what's called normalization. And that's what I did. I pretended as if the bottom temperature was isolated to one 3-inch layer, just like the surface temperature, or the abyssal temperature. And what we found here was a significant temperature increase in the abyssal ocean. But here's a second factor that complicates that even more, compounds that even more. That temperature turns over 4 times a year. So that bar should be 4 times longer than it is on this chart. But I couldn't advertise it that way because it wasn't part of the de Bruyer's study output. I wanted to keep this discipline with the de Bruyer's study output. So I took the de Bruyer's result and matched it to the NOAA published heat content change in zettajoules globally, and it matched exactly. In other words, they agreed. So what de Bruyer saw was that the abyssal oceans were heating significantly. NOAA agreed. And then when I look at the turnover of the abyssal oceans, which simply means when the abyssal oceans get hot, that water exits and it leaves and it goes to the surface. Hence, the speeding up of global or ocean currents by 25% over the last 20 years. That water turns over 4 times a year, so that bar should be 4 times longer than that, which tells me plainly that the heat is originating from below the abyssal oceans, deductively, through this series of critical path questions. Complicated chart, but hopefully that makes sense, that when we normalize, many times we get the true, clear picture. When we're not normalized, the picture is fuzzy, just like a camera that's out of focus. All we're doing here is focusing the camera. So when we look at it, this is the general picture. We have coming out of the asthenosphere arguably a 15 to 20 degree hotter asthenosphere, which is the mantle, roughly, but it's a very thick, it's where volcanic lava comes from, the asthenosphere. That's 15 to 20 degrees hotter. Science is correct that most of that temperature does not make it to the surface of the Earth, but 1 or 2 degrees do make it to the surface of the Earth through thermal vents, through seamounts, through trenches. And that delta T, as it is marked here, immediately departs the abyssal region and goes to the surface and becomes climate change heat. So this is, on the left, we're depicting that principle here and showing the de Bruyer's normalized heat content by layer. But on the right, there's a curious factor here, that when you take the centroid of the heat in the de Bruyer study, the centroid of the heat is below the average bottom of Earth's abyssal oceans. How can that be? I'd put it another way, that means that the deeper we go in the abyssal oceans, the hotter it gets. But under the principle of compartmentation, another Navy principle here, those hot regions don't communicate with the surface. They only express outward, but they don't receive inwards. So those are not areas that can receive heat from the surface as climate change proposes. And if the heat is below those areas on average, that means QED, quod erat demonstrandum, the only possible origin for this heat is below the abyssal ocean. No ifs, ands, or buts about it, because the heat gradient is below, the centroid is below the average ocean bottom. So we waited with that sort of argument in stasis until we got a program called Deep Argo that was begun in 2022 in earnest. It's still only a couple hundred observations, so it's only in its infancy in 2022. When we looked at 2022 and compared it to 2023, there was indeed, the Deep Argo program, even in the limited sampling that they ran, indeed showed a temperature increase in the abyssal oceans. And so when I ran the total thermal energy, if I took this profile, extrapolated it out to all the abyssal oceans on the Earth, and then calculated the thermal energy entailed in that heat pulse, it equated to 95% of the sea surface temperature pulse that arrived that spring, the chart we looked at previously. In other words, the abyssal heat pulse that arrived in 2023 could fully explain from an energy perspective the heat that arrived at the sea surface and then into the atmosphere subsequently in 2023. So we looked at I guess, the need to question the climate change doctrine under this. I hate doing that because I really, 20 years ago, I was solidly on the climate change side. I designed energy plants, waste energy plants, and one of the things that I was adamant about with my clients was that on the output side, we put in what's called an economizer. And that simply means that when the emission stack blows its exhaust out, it goes through this series of pipes. And those pipes are coated with a carbon reactive compound such that it would extract 85 to 96% of the carbon dioxide out of the emissions. And that was important. The problem was only 2 companies that made it, and it was horrendously expensive. But at that time, the margins in energy would support that. So most of the clients agreed and said, yeah, let's go ahead and put the carbon scrubbing economizer in the design, and indeed we did. So over those years when we developed those concept designs for those power plants, where I was the engineer there, we spent tens, hundreds of millions of dollars invested in climate change. So I was a believer in it. The problem is when I go to look and tested it, I didn't find what I was hoping to see. So I developed this chart that basically shows the principle. 238 watts per square meter is the solar budget coming into the atmosphere. It's higher than that outside the atmosphere, but once it is net reduced by the Earth's albedo, it comes in at 238 watts per square meter. 0.087 watts per square meter is the old figure for geothermal budgets. Not big at all, but the problem is there's a 10,000 to 1 degrees of freedom applied in a 97% unobserved domain. That's a fancy way of saying we don't actually know this. So this is called by Thomas Kuhn in his Theory of Scientific Revolution, or whatever the name of the book was. It's called a taxonomic incommensurability. In other words, apples to oranges. The solar budget is apples and the geothermal budget is oranges. Therefore, we don't actually have a scientific argument. We have a social argument, but not a scientific one. So this is a formal refutation in Kuhn. Ideally, or conceptually, once heat comes up from the geothermal source, the tundra releases carbon dioxide, the oceans release carbon dioxide, the methane vents release methane. The sources of this carbon dioxide, that curve in the carbon dioxide that we saw in the temperature and carbon dioxide curve earlier, the reason it's accelerating is because the heat is accelerating the carbon out of multiple sources. That's why it's curved and not linear with the heat, with the temperature increase. So, this introduces the idea that, okay, if the heat is coming from beneath our feet, then how is it being originated? That's where we come back to this entire argument. And this I formulated while I was managing the exotic materials lab during those years. As you can see here, there's a place on the separation of the core and the mantle. That's the core mantle boundary. The area just above the core mantle boundary is called the D'' layer. That's our main candidate under ECDO theory for the decoupling, the point of decoupling. And we'll look again at those forces that keep us coupled right now and how when they are removed, we become a gyroscope. The D' layer is where this coupling occurs. And then we have the upper and lower mantle. We have this thynosphere, the lithosphere, hydrosphere, and atmosphere. If I remember all the spheres that occur. So this is the standard model of how the Earth's distribution of mass is generally understood. So you've got inner core and outer core. That creates, those two together create the magnetic field, geomagnetic field, which then locks the upper portion, or what is deemed on here the H layer, where the olivine is. If you remember the magnetite that is the form of olivine that we discussed, it's highly magnetic. So there's a union between the inner and outer core and this band of olivine that exists up here that holds us in place magnetically during state one. So we just briefly look back. Remember, we've got viscous coupling between the core and the mantle. We have electromagnetic coupling between the core's magnetic field and the magnetite, the extensive amount of magnetite that's in the mantle, the olivine. We have Lorentz charge particle force that's holding the coupling in place, just like an electric motor. We have topographical coupling. And under ECDO theory, when the core sloughs off its material, it creates an infinite lubricant. So we lose number 4, and we lose number 1 when the sloughing occurs and the heating of the earth begins to happen. And when we get a weakened GM field, we lose number 2 and we lose number 3. And number 5 is like 1% of the issue. So number 5 is easily overcome by the 3-moment mass of the earth. So just touch on that. So when we look at this hexagonal close pack, again, that metal bar we had here was part of our studies there. Titanium. Titanium is hexagonal close pack in its native state. When you release titanium, and we had to do some of these tests in our reactors that were in our lab, when you release titanium and force it into this face-centered cubic configuration, it releases a massive amount of energy. Titanium is really odd like that. Titanium is light, but it's not strong. One of our tasks at the lab was to change the nature of titanium. In jet engines, we use titanium as the vanes which vector the thrust and allow the YF-22, or the F-22 now, to make these exotic turns. But that titanium is vulnerable. It's vulnerable to, you name it, it's pretty much vulnerable to it. Titanium is not strong, contrary to the implication in the name. The reason we use it is because it's extraordinarily light. And it's stronger than aluminum. Aluminum is light, but it's not very strong at all. It would melt in a directional vane very quickly. So titanium is our metal of choice. Well, what the Air Force and the Navy came to us and said, look, we're changing out these vanes every 6 months. It's an incredible cost. If you can change the nature of this titanium hexagonal close pack matrix such that it is hardened like your 304 steel that you've done here, then that's worth hundreds of billions of dollars, but even more so in terms of military readiness, the logistics required to support the control and vectoring components inside jet engines would change the nature of air combat. So that's what we worked hard on. So we studied hexagonal close pack matrices and how to get them to work with this interstitial solution that we had. But here we see what I believe is the cause, the origin of the geomagnetic field. You have in a hexagonal close pack array, you have what is called the right-hand rule. The E field moves like your fingers here. It moves in the horizontal plane. And when the E field is strong, the M field is perpendicular. The magnetic field is perpendicular to that. This is called the right-hand rule. And you can see it up here. So when the Earth's core is highly charged, and its magnetic field is strong, or its E field is strong, I'm sorry, then consequently its magnetic field increases at the same rate. So the question is, how does it cycle back and forth? We're losing the magnetic field right now, so we know we're losing this integrity, we're losing the E field integrity, we're definitely measuring that we're losing the M field integrity. What's causing that? And if the Earth's going to flip over, why wouldn't it just stay flipped over? What would make it flip back? That's where Ben's principle comes into play. The A and the phi scalar fields of the sun recharge this E field matrix inside the core. So this disarray that exists in the core, the loss in the hexagonal close pack alignment, so that the E fields are all parallel or to the horizon here, that goes away when we lose our M field. But when the sun recharges it, the E field gets strong again, and the geomagnetic field builds commensurate with that, and we go back into state 1. In other words, the sun is a wireless recharging, conducting wireless recharging of our core. Hence the connection into the solar cycles that Ben has outlined. That's why our theories, they fit together well, at least conceptually at this point. So anyway, sorry to get too much in the theoretical physics there. There's the enthalpy, which is fancy word for heat coming out of this phase change. So the broader solution that we proposed is that climate change originates as a result of this transition of core material from hexagonal close pack form into face-centered cubic form, principally with the iron and also with the nickel that occurs there. So when we're sloughing material off this core up into the LLVP structures, that material is releasing an incredible amount of heat. And we already talked about the first and second laws of thermodynamics. That heat doesn't disappear, it has to go somewhere. And arguably, that's the origin of these anomalous heat signatures coming out of and through the abyssal oceans. So that's what sealed up ECDO theory on this. I won't go through this whole chart, but it's basically that enthalpy goes and rises to the surface, increases our output of methane. It forces carbon dioxide out of our alkane stores or crude oil stores that are way below what we can get to. And it all creeps up through the surface and becomes, and volatile organic compounds come from those oil reserves as well, and becomes the impetus of our climate change, the nonlinear relationship that we saw with the carbon curve. So that was ECDO theory. It all hinges, that's the phase chart for iron right there. We move from epsilon iron into, I believe it's gamma iron, if I remember the names correctly, but we're moving from hexagonal close packed to face-centered cubic, in essence. And that's what creates the boundary between the core and the mantle. And then that heat rises up through these structures. There's a color version of this on the website, but I had to use black and white for the book. But basically, all these sources of carbon dioxide exist under the ground and in the ocean. And when the heat arrives, it forces that it's called carbon forcing. That carbon dioxide is forced into the atmosphere. That's why in 2023, the carbon dioxide jump followed the heat signature by 38 days because it was carbon dioxide forcing. It wasn't the carbon dioxide creating the heat. And climate change missed this. So that's one of the central hypotheses to ECDO theory. So theory comprises hypotheses. There will have to be some predictions that come from this hypothesis set as well. So now we transition and look in at Giza. Giza is its own beast among all ancient monuments. So we know that we've identified 93 ancient monuments which bear obsequience to NP prime. Fancy way of saying they are so old they point at a former North Pole for that reason, for the reason of ECDO.
It is evident that since the onset of the Bronze Age, some intelligence concerning this pyramid threatens the powers that rule over us, terrifying them into committing despicable acts of pseudo-epistemology.
And I hate this type of conspiracy spinning because it's conjecture. And you need to make it clear that it's conjecture. But it is clear as it regards these ancient monuments, as it regards Göbekli Tepe, Karahan Tepe, as it regards Giza in particular, that there is some agency out there that doesn't want these secrets broken. And I hate to say that, but I think it's a fact. Now, why? The ultimate reason why, we can only speculate on that. But they have stood in the way of scientific progress. They have used these inferior versions of science to prove an answer that they had already invented in 1847 when Howard Weiss entered the chambers above the Khufu Pyramid's king chamber, the relieving chambers. They already had the answer in mind that they wanted in the early 1800s. But why? We didn't have the information in the early 1800s. Why would you invent the answer then? Surely you know as a scientist you've got to have a good sound basis of deductive evidence in order to create an answer, but yet we created the answer and then went out looking for the evidence. Giza helps us in this regard, that whoever devised Giza did so on 2 or 3 levels of intelligence. They patterned Giza such that we wouldn't understand it at face value. It would look like a curio. But inside it are messages that, once you understand ECDO theory, suddenly make complete sense, especially as regards the Khufu Pyramid or the Great Pyramid. This is what I call the tripartite observatory. Curiously, and this is after the fact, when you measure the angular distance between the shafts that come out of the Queen's chamber and the King's chamber, they're both at 104 degrees. But even more than that, the King's chamber shaft, north shaft, points directly at our current Polaris North Pole, celestial North Pole. And the south shaft points dead on NP prime. And they're purposely bent off